As we mentioned previously, setting the tool as precisely as possible to the surface of our workpiece is very important. Now, with our tool exactly on the workpiece surface, it's very easy to adjust our cut to remove precise amounts of material. If we're not exactly on the surface, then we're going to be off on our measurements, playing catch-up at best, and ruining our workpieces at worst. So we need to be able to just set our bit on or against the workpiece without cutting into it in order to set our zero reference point. Now, there's a plethora of ways to do this, and different ones work better for different folks. Some folks simply lower the tool onto the stock until it just begins to scratch the surface, and they'll set that as their zero reference point. Now, for a lot of projects, this will work fine. If there's a lot of extra material to play with or the top of the surface is uneven, this isn't the worst way to begin. So let's go ahead and demonstrate that. This is a piece of extruded aluminum stock. The end has been bandsawed, and it's not very accurate. We need to mill the sawed end into alignment with the sides of the stock, squaring it. So we'll put it in the screwless vise, with one side squarely against the solid jaw of the vise, and we'll use a mini square to align the front of the stock. I'll put a little tension on the vise to hold things in place, and then we'll make sure that everything is aligned. Our stock is aligned to the mini square and the bottom of the square to the vise bottom. With this in place, we'll clamp the vise on the stock. And we'll double check to make sure it didn't move during clamping. Next, I'm going to put a small block on the vise and run the square over it. Doing this, I can easily see which part of the stock is highest, the front left corner to be exact. We'll set that front left corner directly beneath the spindle, and after spinning by hand, we'll fire up the mill on a slow speed and lower the bit until it just touches the stock. Now, since I know no place on the workpiece is higher than this, I can go ahead and dial in a few thousandths and start making my cuts. Each pass gets the stock closer to square, but you can see easily that the bit still isn't touching the low spots. Finally, the entire top surface is machined and square to the sides. So, all in all, that's not too bad a way to get started with rough cut material. But what about when you need to lower the spindle onto a precise machined surface where there isn't a lot of excess material to play with and not a lot of room for error? Let's discuss a couple of quick, easy ways to do that. One of the ways is to use a common feeler gauge. Now, this sounds fairly simple, but in reality it takes a bit of practice to get it right. The theory of the method is this. You place a precisely ground strip of steel, the feeler gauge, between the bit and the workpiece, and then you lower the bit onto it. When you remove the gauge, you'll simply have to dial in the thickness of the gauge to lower the bit exactly onto the work surface. Let's give it a try. Here's our setup. We'll use a 2/1000 gauge to start with. Now, some folks prefer to use thicker gauges, and that's fine if it works for them, but the thinner gauge will flex a bit more and thus possibly allow more feedback, as it were, to the operator. We'll lower the spindle until the bit is just touching the gauge, at which point we'll drag the gauge back and forth until it just slips between the workpiece and the bit. Now, this is where the thinner gauge comes in handy, in my opinion. A thicker gauge can be forced past more friction than a thinner one and could give a tighter reading. At this point, we'll dial in another 2/1000 to account for the feeler gauge and zero out the spindle hand wheel. We'll rotate the spindle by hand, as always, and see how everything looks. Now, you can see that the bit is cutting through the metal die. We do want it to scratch the die, but not cut much deeper than that. Let's fire it up and make a quick pass along the x-axis to see just how much metal is removed. Well, pretty much all the metal die is obliterated, which isn't bad in itself, but there was a tiny bit of metal removed too. Now, it's well under 1/1000th of an inch, but it is noticeable. As I said, this method works great for a lot of folks, but it does require a bit of practice to get the touch, so to speak. Let's move on to another approach. Old-timers often used paper to set tool height and had very good results doing so. Now, I know it might sound a bit archaic and perhaps less precise than using a precision ground bit of feeler gauge stock, but if there's one thing I've learned over the years, it's never dismiss old-timer methods without first thoroughly investigating them. Now, I've used all kinds of paper doing this. We'll discuss that more in a moment. But for this particular method, I like regular zero-graphic paper, the cheapy stuff like you'd get at Costco or Sam's for your computer printer. It measures, normally, close to 4/1000th of an inch in thickness. We'll take a piece of this 4/1000 of an inch paper and put it between the bit and the stock. Next, we'll lower the spindle until it just begins to rub against the paper. Now very, very gently continue to lower the spindle while moving the paper back and forth. We want the paper to slowly start to resist. If it locks up kind of quickly, raise the spindle up a bit and start again. When you get it right, the paper will go from sliding freely to starting to drag, getting a little draggier. Then it's going to snag, lock up, and tear. At this point, go ahead and remove the paper. Now, I'll dial in 1/1000th more on the spindle. It's been my experience, and this is totally subjective, it may be different for you, that notebook and copy paper in the 4/1000th of an inch thickness range tears when there's close to 1/1000th left between the bit and the stock. Now we've spun the mill by hand. Now we'll make a pass and see what we got. It's like I said, never dismiss old-timer methods out of hand. The bit has barely cut through the die. You can even see the previous machine marks on the surface of the workpiece. We're talking well under 1/4 intrusion into the material in my best estimation. Now this method is very easily mastered and probably will become a staple in your personal repertoire, as it is in mine. But I've never believed in leaving well enough alone. I don't know why that is. It's just a personality defect, I guess. At any rate, I've modified this method just a bit to make it a little easier. I like things easier usually. I do this through the magic of special machinist paper. Now, strangely, this paper isn't sold, as far as I know, at industrial supply shops. The only place I've ever managed to locate it, believe it or not, is at a tobacco shop. Apparently, some folks use machinist paper to make cigarettes. I know it sounds crazy, but it's true. At any rate, machinist paper comes in different sizes and from different manufacturers. The machinist paper that I'm using comes in a small packet of 32 sheets for about $1. Now, the sheets are 2 3/4 by 3 inches, and they have a fold down the center that makes it very easy to tear the two pieces evenly. This cuts the cost down per use to about 1.5 cents. Now, perhaps you're wondering why I would choose to pay for this special machinist paper instead of simply using readily available copy paper at a fraction of the cost. Well, no, it's not because I use it for any other reason. I don't smoke, unless I'm actually on fire. The reason I love machinist paper is it's uniformly super thin. Most brands are 1/1000th of an inch thick or less. So when the pointy bits of our tool cut into the paper, they are, for all practical purposes, in contact with the material. Let's give it a try. The procedure is the same as with the copy paper. Just make sure you feed very slowly so as not to overshoot. You'll want to stop lowering the instant the paper locks up, before it tears. Once it locks, now you can go ahead and tear it and remove it. Give the mill spindle a spin by hand, as always. And go ahead and zero out your spindle hand wheel at this point, too. Now we can fire up the mill and see how we did. Pretty good, huh? Look how much metal die is left. This is about my favorite method of setting the cut height. Now this paper method can also be modified with the machinist paper to work for side milling. Let's say we want to mill a precise amount from the end of this workpiece. The piece needs to measure 1.525, but as we see here from our micrometer reading, it currently measures 1.5255. It's a 1/1000th oversize. Now that's pretty close tolerances. We're going to need to set our mill bit very precisely so as not to overshoot. So we'll put a piece of machinist paper between the mill and the stock, and we'll use a piece of low-tack masking tape to hold it in place. This is much safer than trying to do it with your fingers, so use the tape. After that, we'll lower the bit down into place in about the middle of the workpiece. Next, I'm going to fire up the mill and set the RPM very, very slow, and then feed the bit towards the stock. The moment the bit cuts through the paper, I'll stop feeding. At this point, you need to listen very carefully. If your mill bit is in perfect shape, you might not hear anything. If so, dial in a scant 1/4 to 1/2,000th more. You should just hear a very faint rhythmic thumping sound. That's the bit just touching the surface. If your bit is less than perfect, you'll probably hear that sound the second the bit cuts through the paper. That's what happens this time, so let's listen for that sound. There. That's what you want to hear. It's faint but noticeable, that thumping. Now, we'll dial in the half-thousandth we wanted to remove, we'll fire up the mill at our chosen speed, and we'll make a conventional cut across the side of the stock. Without changing depth, we'll allow the bit to make a climb cut on the way back. That'll give us a very nice finish. Now, please pardon my arm here as we take another measurement and see how we did. That's looking very good. I'm going to lock the mic in place so we can show you the reading right in front of the camera. What do you think? That's pretty much as close as I'm going to need it. All of the methods we just demonstrated to you are good. You may find that you have better results with one than you do the others, and so by all means use what works best for you. But as always, we wanted to offer you different choices. Not every situation is going to be served by paper or feeler gauge or by simply touching off the stock by feel. A good mechanic has more than a crescent wrench in his toolbox, and likewise, a good machinist will have more than one usable technique for any operation in his repertoire. So practice and play with all of them. As you get comfortable, you'll find yourself modifying and even inventing methods of your own. And that is just one of the fun aspects of metalworking. When you're ready, we'll move on. Our fly cutters on previously milled surfaces which are precisely set up on our mills will use the same methods for setting tool height as we mentioned before. The machinist paper obviously is one of my favorites, and especially so for fly cutting. Again, as soon as the paper locks, I'll stop lowering the spindle, then I'll go ahead and tear the paper out of there. Great precision, and from there can go on to break or chamfer it if we so desire. Now for non-demanding work, you can often simply touch off the edge of the running countersink to the edge of your stock. But if you're going to all the trouble of setting up a countersink anyway, why not spend an extra moment and do it right? Set the corner of the stock under the middle of the countersink edge. After you've done that, tape a piece of machinist paper between the two. Set the mill at minimum RPM and lower the spindle until the bit just cuts through the paper. That's it, right there. Stop the mill, remove your paper, zero out your hand wheel, and you're ready for a precision deburring pass. That corner is crisp and perfect without a trace of burr, and the only metal you removed is this tiny bit of swarf that was the burr itself. Dovetail bit and set the tool height. Again, there's the ubiquitous machinist paper. I usually just touch the dovetail bit off the stock. Now you feed the bit very gradually and watch and listen for the moment